Hey, what's up, everyone? Today we are starting activity 7, which is called parallel and perpendicular lines. Okay, so we will be dealing with parallel and perpendicular lines, obviously, and then today, and the way how we're going to do this is with this scenario through Patios by Madeline. So you'll see it's kind of a real life scenario, kind of where we see parallel and perpendicular lines in the real life, in the real world. So this video consists of lesson 7-1, which is titled Parallel Lines and Angle Relationships. So we'll just be dealing with those parallel lines and then the angles that are formed from parallel lines. Alright, so as always, let's go through our learning targets. For this lesson, our first learning target will be to make conjectures. We're making conjectures about angles formed by a pair of parallel lines and a transversal. So we know what angles are, we know what parallel lines are, we're going to learn about what a transversal is today. We will also prove theorems about these angles. Okay, so let's talk about the premise of what this actually entails. So we have Matt. Matt works for a company called Patios by Madeline, as we talked about above right here. A customer has asked him to design a walkway. The rows of bricks in the patio will be parallel to the walkway, as shown in the diagram. So if we look at our diagram right here, this is kind of how, if we look to the right, this is kind of how our patio will look. And if you see that every single row of bricks are parallel to each other, my lines aren't, and what does it mean for things to be parallel? So we look at our math terms to the right. It says two lines or parts of lines are parallel if they're coplanar and they do not intersect. What we mean by coplanar is that they just lie in the same plane, meaning that we're dealing with all this. If we have a flat plane, all the lines are in the same plane, and then they don't intersect. That's the biggest thing we need to know about parallel lines, is that they do not intersect, never intersecting. Okay, that's important. So far Matt has used stakes to tie down two parallel strings that he can use to align rows of bricks. So this is our end product right here, but right now this is all we have so far, these string lines. He also used paint to mark the underground gas line to the house so that he can avoid accidents during construction. The string lines and the gas line intersect to form 8 angles. So our string lines are parallel. So I want to introduce a symbol that you might not see yet, but it's important and you will see it later on in the course. If I put arrows like this, that signifies that those two lines are parallel. That's just a symbol to signify parallel lines on a diagram. Okay, so these two string lines are parallel lines. We have a gas line that intersects those two string lines. Okay, and we see we have 1, 2, 3, 4, 5, 6, 7, 8 angles that are formed when this gas line intersects these two parallel lines. And what we're going to be doing, we're going to be using this whole scenario to explain the relationship between parallel lines when they're cut by some line, which we actually call a transversal. And we're going to go over, let's go ahead and turn to the next page and we can see some definitions before we start answering some questions. All right, on the next page, before we even look at number 1, I want to look over this left sidebar on the side of math terms. All right, let's read the first one. A transversal is a line that intersects two or more coplanar lines in different points. Okay, so it's just a line that intersects two or more coplanar lines, meaning that the lines are on the same plane in different points. So I want to tell you right now, a transversal does not have to intersect parallel lines. It's just one line intersecting two or more lines that are on the same plane. Okay, but what we're gonna talk about in this section more with parallel lines like that. But anyway, okay, when two lines are intersected by a transversal, corresponding angles, our first type of angles, pairs, are a pair of non-adjacent angles. So, okay, first pair of non-adjacent angles. Non-adjacent angles means that they do not share a vertex and they do not share a side. They're not next to each other. Okay, such that the angles are on the same side of the transversal, and one angle is outside the two lines and one angle is between the two lines. So I have two lines cut by a transversal. An example of corresponding angles would be, let's say, this one and this one, or this one and this one. Excuse me. Let's call that Y, Y. We can also think of, let's see, Z and Z, and then how about A, A. Those are your corresponding angles right there. It just means, what it means is that, let me draw this again. Remember we said that they are on the same side of the transversal. So if this is my transversal, this line cutting down the middle means they're either going to be on the right side or the left side of that transversal. And then one angle is outside the two lines. So let's say this one right here, outside the two lines, and then one has to be in between the two lines. So I'm going to choose that right there. Why couldn't it have been this one? And this comes, it cannot be this angle where the arrow is because of the fact that they are non-adjacent. Non-adjacent is the key there. Gives us that the only choice for this angle, for an angle corresponding to this one, has to be that one. Anyway, next, for same side interior angles. So you see same side kind of gives away some of the properties of these angles. Same side interior angles are a pair of angles that are between the two lines, all right, and on the same side of the transversal. So I know they're between the two lines. So I'm either right here, these two angles are those two angles, okay? And there's going to be, for same side interior angles, this is one pair of same side interior angles because they are on the same side of the transversal and in between the other two lines. Our other pair would be these two because they're on the same side and in between the two lines. Okay, alternate interior angles. So these interior and right here and these interior, those keywords in the definition or the name mean that they are in between the two lines. Interior means in between the two lines. So they are a pair of angles that are between the two lines and on opposite sides of the transversal. So if I'm opposite sides of the transversal, an alternate interior angle to this angle would be right here. I know it's right there, and it's only right there because it's inside the two lines and on opposite sides or alternate sides of the transversal. The other pair of alternate interior angles would be these two. Okay, so that's a little explanation of the angle pair, type of angle pairs we have, and what a transversal is. So what I want you to do right now is I want you to pause the video, and work numbers 1, 2, and 3 on your own. Okay, you're going to work those out, and when you're finished, unpause the video and we will go over together and you can check your answers. Alright, so we are back, and if you're reading number 1 correctly, you have seen that you probably needed to grab your protractor, okay? So, because number 1 says, use a protractor to measure each of the numbered angles formed by the string lines and the gas line on the previous page. So, when we're using a protractor, we put our protractor up on the vertex, the center of the protractor on the vertex of the angle, and we find out the angles. So in my previous video, I've posted a video on how to use a protractor, and so we'll have, if you do not remember how to use a protractor, please reference that video. Alright, so I've gone ahead and measured all these beforehand, and I'm going to just give you the answers for these 8 angles. So the measure of angle 1 is 115 degrees. Measure of angle 2 is 65 degrees. Measure of angle 3 is also 115 degrees. Measure of angle 4 is also 65 degrees. Measure angle 5, 115. Measure angle 6, 65. Measure angle 7, 65. And the measure angle 8 is 115 degrees. So, if you're looking at this, wow, we have two different possibilities for all these angles, either 115 or 65. Think about that. That might come in handy in a second. All right, number 2. The gas line is a transversal of the string lines. Remember, if you don't remember what a transversal is, please refer to the math terms on the side. We want to name the angle pairs formed by these lines that match each description. So what we're going to do is we're going to take these definitions and we're going to pick out the angle pairs and such from our example on the previous page. Okay, so if we look at it, it says that the gas line was our transversal. So this line right here is the transversal of these two parallel string lines. Okay, so we want to find 4 pairs of corresponding angles. So on this one, we know that corresponding angles are on the same side of the transversal. Okay, so the same side of the gas line. And then we want to, one is on the outside of the two lines and one is on the inside of the two lines. And they're non-adjacent. So there are 4 pairs of corresponding angles. So angle 1 is a corresponding angle with, that's what I'm going to use for my pair. Angle 1 corresponds to angle 5 because they're both on the same side of the transversal, which is the gas line. One's on the outside, one's on the inside, and they're non-adjacent. So angle 1 and angle 5. We also have angle 2 and angle 6. We have angle 3 and angle 7. And angle 4 and angle 8. Okay, so 1 and 5, 4, 7, 2, 6, and 3 and 8. Okay, that's what we have written down here. Excuse me, just 1 second. My apologies. I was doing this without looking. It should not be. It should be 1 and 5 is correct. 2 and 6 is correct. 3 and, the book had it wrong, if you just excuse me. 3 and 8. And 4 and 7. I apologize if you've got that incorrect and you were confused. Should be 3 and 8 and 4 and 7. I wrote those down wrong. My apologies. 3 and 8 and 4 and 7. Alright, for same side interior angles, there are 2 pairs. Remember, if they're same side interior angles, that means they're on the same side of the transversal and they're both interior, meaning they're both inside the 2 lines. So our 2 pairs will be 3 and 6 and 4 and 5. Angle 3, angle 6. Those are our 2 pairs of same side. I find that same side interior angles and alternate interior angles are the easiest ones to find. Alright, for alternate interior angles, we kind of just switch it up. We kind of make a cross right here. Angle 4 and angle 6, and angle 3 and angle 5. Alright, so number 3. Based on your answers in items 1 and 2, make a conjecture about each type of angle pair formed by parallel lines and a transversal. So this, as we get here, this is where it becomes important that the 2 lines are in fact parallel. We're going to make a conjecture based on the angle measures we found in number 1. When I say a conjecture, I mean a guess. We're going to make a guess about the measures of these types of angles. So if I look at part A, 1 and 5. 1 and 5 are both 115. Okay, let's check 3 and 8. 3 and 8 are also 115. 2 and 6 are both 65, and 4 and 7 are also both 65. So they have the same measure, it seems, that corresponding angles might have the same measure. Another way to say that is I'm going to guess that corresponding angles are congruent. Okay, that's my guess. Corresponding angles are congruent. And remember, this is only if the two lines are parallel. Only if the two lines are parallel. Important. Okay. Same side interior angles. So, let's look at our pairs of same side interior angles. Angle 4 and angle 5. 65 and 115. Those aren't the same. What else? Let's try adding them up. 65 plus 115 is 180 degrees. Wow. If I can add two angle measures up to equal 180 degrees, what does that mean? It means they're supplementary. So let's check and see if the other pair works out that way. Angle 3 and angle 6, 115 plus 65, also 180. So I'm going to conjecture, or I'm going to guess that same side interior angles. So same side interior angles are supplementary. That's what I'm guessing. They're supplementary. For C, let's look at our alternate interior angles. 4 and 6 are the same angle. 3 and 5, same angle. How about we guess that alternate interior angles are congruent as well? Alright. That looks great. I hope you can read my handwriting. Sorry. Those are my guesses, okay? So, using this, let's move on. Alright. Next, I want you to pause the video, and I want you to work numbers 4 and 5 on your own before I go over them with you, okay? Alright, and we're back. Number 4. The lines below are parallel. I'm going to go ahead and just draw these little arrows right here so I know they're parallel and we know they're parallel. I want us to just draw a transversal to the parallel lines. That's just a line that cuts through both lines. So, boom. That work? Okay. So, I'm okay with that. You could have drawn it the opposite way. You could have drawn it straight up and down if you wanted to. Whatever. As long as it cut and intersects those two lines at different points. Okay. Number the angles formed above and record the measure of each angle. So, what I'm going to do, I'm going to number them. We're not going to measure the angles because we kind of did that already. So, you can measure all yours with a protractor. What you should find is that, and see what you should measure your own parallel lines, and you should see, do they look the same? Do they what what's the word I'm trying to say? Do they fit your three guesses right here? That's what I'm trying to say. So I'll still number these like 1, 2, 3, 4, 5, 6, 7, 8. Okay. What you should find is that they do confirm your guesses that you've made. All right. So do your answers, that's what number 5 says, do your answers to item 4. Confirm the conjectures you made in item 3. Explain and then revise your conjectures if needed. Okay, so yes, they will confirm the conjectures. If you find that they don't, how about we go back and look at your conjectures, see if what you might have done wrong than what I did, or if not, you might have measured your angles wrong. But if you drew a very straight line for your transversal, you should have the guesses that I made right here should be reflected in your measurements, okay? All right, let's quick move on. All right, our next, I want you to do number 6 and 7 on your own. Please pause the video right now, and then I will go over them in just a second. So, we're back. The corresponding angles postulate involves angles formed by two parallel lines cut by a transversal. So based on your earlier conjecture, write the corresponding angles postulate in if-then form. We remember with if-then form, we have a hypothesis and then a conclusion. So if something, then something. So you might, don't be scared and don't be freaked out if your answer is not exactly like mine, because I'm actually going to pretty much write down the actual statement of the corresponding angles postulate. There might be a few details you may need to add in there, okay? So, if two parallel lines are cut by a transversal, then the corresponding angles are congruent. Alright, so if you said if two angles are corresponding, then they are congruent. Let's think about why that is not. Why that's not always true, first of all. If two angles are corresponding, that just tells me nothing about the lines that are cutting through it all. That tells me nothing about the lines themselves. Okay? All corresponding angles are not congruent. They're only congruent if the two lines that we're dealing with that are being cut by the transversal are parallel. So the big thing, or the given that we have to have, is that the two lines are parallel. So that's why it's in our hypothesis. If two parallel lines are cut by a transversal, then the corresponding angles are congruent. We don't know they're congruent if the lines aren't parallel. That's what we're trying to get across right here. So, do you need to prove that this postulate is true before you can use it as a reason in a proof? Answer is a big old no. And that comes from the fact that postulates do not have to be proven. Postulates are accepted as true. Alright, now, number 7. The alternate interior angles theorem and the same side interior angles theorem also involve angles formed by two parallel lines cut by a transversal. What I want you to do again, I want you to pause your video again, and I want you to see if you want to revise what you wrote for A and B of number 7 based on what I have given you for part A of number 6. Okay? I've given you kind of the format you need for that. So see if you can rewrite number 7 based on number 6. Alright, and we're back. I hope you revised your number 7 if need be. If you think you're still correct, let's see. So based on your earlier conjecture, write the alternate interior angles theorem in if-then form. So here we go. Using my format from number 6. If two parallel lines are cut by a transversal, then the alternate interior angles congruent. I guessed earlier that alternate interior angles are congruent when the lines are parallel, so that's what we got there. Again, if you still think that your part B, if you still have not changed anything and you got part A wrong because you did not use the format from 6A, pause your video now, see if you can fix your part B to look very similar to what we have done in 6A and 7A. Alright, for same side interior angles theorem, we're going to say it is if two parallel lines are cut by a transversal, then the same side interior angles are supplementary, because that is what we guessed earlier. Alright, I want you to go ahead and also write the corresponding angles postulate on your list of justifications, because we do not need to prove it, so you can use it in a proof now. Okay, we have not proven the latter two, so don't write those on your list yet, because we can't use them just yet, because we have to prove them first. Alright, next, I want you to pause your video. I want you to do 8 through 11 on your own, and then we will check your answers, okay? Alright, and we're back. In the diagram, line L is parallel to line M. So what I'm going to do is I'm going to go ahead and just put these little arrows right here showing that. Use the diagram for items 8 through 10. Alright, number 8. Explain how you know that angle 4 and angle 6 are same side interior angles. So, angle 4 and angle 6. I know they're same side interior angles because they're on the same side of the transversal and both are between the parallel lines. So, same side of transversal, both. So they're both between lines L and M. That's what it means to be a same side interior angles. Alright, number 9. Are angle 2 and angle 3 corresponding angles, and explain how do you know? They are not. And the reason I know that they're not is because they are adjacent. Okay, we know that corresponding angles are non-adjacent angles. So that it tells us why 3 cannot be a corresponding angle to angle 2. Number 10. If the measure of angle 5 is 65 degrees, then what is the measure of angle 4? So measure of angle 4 and 5 are alternate interior angles. We know that by the alternate interior angles theorem, they are congruent. So that if the measure of angle 5 is 65, then the measure of angle 4 is also 65 degrees. And that's because they're alternate interior angles. Okay, the little angle sign, I'm just doing a little shorthand there. Okay. 11. Angle BCD and angle CGE are corresponding angles formed by two parallel lines cut by a transversal. Alright, that means that they're congruent. We know that, okay? Given that the measure of angle BCD is equal to 3x plus 6, and the measure of angle CGE is equal to x plus 24, complete the following. A, what is the value of x? So BCD and CGE are congruent. So, measure of angle BCD is equal to the measure of angle CGE. So substitute the values. 3x plus 6 equal to x plus 24. subtract x from both sides, we get 2x, and then subtract 6 from both sides, so 2x is equal to 18, and x is equal to 9. There's a little algebra there. What is the measure of angle BCD? So we're going to plug in 9 for x in the measure of angle BCD. So it's 3 times 9 plus 6. So that is 27 plus 6. So the measure of angle BCD is equal to 33 degrees. Explain how you found your answers, and the whole thing that this rests on is the fact that corresponding angles are congruent. That's what I'm going to write. That is what allowed us to do this statement right here. It allowed us to set those two angles, the measure of those two angles equal to each other. And then from there, we were able to solve for x. Okay? All right. If you have questions with any of this, we can answer in our question session, or you can also shoot me an email. All right. Number 12. So what I want you to do is I want you to complete number 12 on your own, or attempt to complete number 12 on your own. It's a proof, guys, so it's a little bit scary, but I want you to pause the video and give it a try before I go ahead and go through it, okay? All right, and we're back. Number 12 is we're reasoning quantitatively. It says to complete the following proof of the same side interior angles theorem. So we're now proving same side interior angles theorem. Once we've done this, you can then add the same side interior angles theorem to your list, and we'll be able to use it for proofs from now on. All right, so we have our diagram here. We are given that line M is parallel to line N. We want to prove that angle 4 and angle 5 are supplementary. So if you see that on the diagram, angle 4 and angle 5 are same side interior angles, right? We want to prove, we don't know for sure, since we're proving the theorem says that same side interior angles are supplementary, so we want to show that one pair of, on this diagram, are in fact supplementary. One pair of same side interior angles. They could have chosen to do angle 3 and angle 6 as well, okay? But they chose angle 4 and angle 5 down. All right, number 1, we want to give the reason for statement 1, which is that M is parallel to N, and of course that's just the given. Step 2 of the proof tells us that angle 1 is congruent to angle 5, and that's by the corresponding angles postulate. Remember, we're able to use this postulate in our proofs because the postulate does not need to be proven. Okay, so we didn't have to prove the corresponding angles postulate first to be able to use it in a proof. So I know that angle 1 is congruent to angle 5 because they're corresponding angles. So from there I can say that the measure of angle 1 is equal to the measure of angle 5, and we know that if two angles are congruent, they have the same measures by the definition of congruent angles. So when I say angles, I'm going to put angle with an S next to it, okay? Just for a little shorthand. All right, I can't see where to go from here. What I can see is that angle 1 and angle 4 are supplementary, and actually, to be specific, they are a linear pair. We've talked about linear pairs before, and there is there's a postulate that tells us that if two angles are a linear pair, then they are supplementary, meaning that they add up to 180 degrees. So, measure of angle 1 plus the measure of angle 4 equals 180. That's by the linear pair postulate. Okay. So, measure of angle 5 plus the measure of angle 4 is equal to 180. So what did I do to go from 4 to 5? I know that the measure of angle 1 is equal to the measure of angle 5 by statement 3. So from 3, we're able to substitute in the measure of angle 5 for the measure of angle 1 to get this statement in statement 5. That's just by substitution. You can put substitution property if you like. I'm just going to write substitution for now. And then now, since the measure of angle 4, then 5 and the measure of angle 4 add up to 180 degrees, I know that the angle 4 and angle 5 are supplementary. I also knew what the statement for number 6 was, because it's the last statement, and that's always the proof statement. Okay. So it's a proof. Not writing a proof yourself, but it's kind of a mixture of doing statements and reasons. I want to go over this. Look at this math tip again. I didn't do it before we did the proof, but I'd like to go over it at least. It says it is sufficient to prove that one pair of same-side interior angles formed by a pair of parallel lines and a transversal are supplementary. What it means by that is that we don't have to prove that both 3 and 6 are supplementary and 4 and 5 are supplementary. We can just take one pair of same-side interior angles in this diagram, and that's enough to show that the whole theorem is proven. All right. So like I said, you could have used 3 and 6. Again, they could have done this, but they set it up in the way for us to use 4 and 5. So that's what we did. All right, moving on. Turn the page. All right, I want you to pause the video and do number 13 and 14 on your own, and then we will be finished, guys. This is the last of this lesson. All right, and we're back. Number 13. Look back at your proof in item 12. Explain how you know that angle 1 and angle 5 are corresponding angles. So they're corresponding angles because they're on the same side of the transversal. One's on the outside and one is on the inside. So same side of transversal. Angle 1 is on outside of two lines. Angle 5 is on inside. They are, God, my handwriting, excuse me. They are non-adjacent. All right, for B, explain how you know that 4 and 5 are same-side interior angles. So they're both inside the two lines and both on the same side of the transversal. All right, number 14. Now we're going to be completing the following proof of the alternate interior angles theorem. So once we finish this, of course, you can put this on your justifications list. All right, let's leave the math tip before we do this time. Do not assume that lines in a diagram are parallel just because they appear to be parallel. You can only conclude that the lines are parallel if 1. You're given this information in the text or in a diagram, or 2. You prove that the lines are parallel. So that's just a good hint, because these could be slightly off, but of course in our given statement we are given that they're parallel. So that's how we know they're parallel, and I'll go ahead and draw my little lines here to show they're parallel as well. What we want to prove is that angle 4 is congruent to angle 6. So angles 4 and angle 6 are alternate interior angles because we're proving the alternate interior angle theorem. And we want to show that they're congruent because our guess and the theorem says that alternate interior angles are congruent when the two lines are parallel and cut by a transversal. All right, this one was a little bit harder because you had 6 different things to fill in. So our first statement is always the given statement. So M parallel to N by given. I hope you got that one at least. Number 2, angle 4 is congruent to angle 2. So angle 4 and angle 2, they're vertical angles. All right, and what theorem says that vertical angles are congruent? None other than the vertical angles theorem. THM will be a shorthand for theorem for you. All right, Angle 2 and angle 6 are congruent. They are corresponding angles. That's the corresponding angles postulate that says that they're congruent. So corresponding angles postulate. All right, I know that my statement for my last step was always going to be my proof statement. So angle 4 congruent to angle 6. So angle 4 is congruent to angle 2. Angle 6 is congruent to angle 2. Since they are both congruent to each other, we say that angle 4 is congruent to angle 6 by the transitive property. All right, so we are finished here. That is lesson 7-1. It was a lot of information. This was a longer video, about 40 minutes long, but this is a lot of good information. Go ahead and complete your homework. If you have any questions, write down your questions for the question session and we'll answer these. All right, and you can go ahead and email me as well. Remember, my email is hunter.patton@cpsb.org. Thanks for watching, and I hope you have a great day and a great rest of the week.